In this video, we're going to convert the polar point -4, -7 pi over 6 into its rectangular form that's equivalent. And so to do this, we're going to use what you see written in blue, where x is equal to r cosine theta, y is equal to r sine theta, and then the other two conversions you see are only useful if we're going from rectangular to polar. So we're not going to use those for this video necessarily, we're just going to use these first two. And the way you can know is if you're given a point and it's in polar form, of course it's going to have that angle, you're going to be given an r and a theta. And what we're trying to find instead is we're trying to find an x and a y value, going back to the normal xy ordered pair thing. And so you can see the first two, the x equals r cosine theta and the y equals r sine theta, are solved for x and y. And so you can just basically plug the numbers in and be done with it. Now that's why I have the unit circle here, because it's going to make the problem a little bit easier on us. And so let's go ahead with the first one. We know x is equal to r cosine theta, and so our r in this case is -4 cosine, and our theta is -7 pi over 6. And so what we want to do is we want to go to the unit circle and we want to figure out where this is. And so we're going to have the -4 right here, but what we're figuring out is what the cosine of -7 pi over 6 is. So since this is on the unit circle and this is cosine, we're looking for the x value at the angle -7 pi over 6. So 7 pi over 6 would be going around to right here, but we're wanting -7 pi over 6. So instead of going in a counterclockwise direction, we go clockwise. And so we're going to go all the way around to here. And so this is -7 pi over 6, so the point -square root of 3 over 2, 1 over 2 is going to be the thing we're going to use for x and our y values. This time we want the cosine of -7 pi over 6, we want the x, so we're going to have -square root of 3 over 2. And then we just want to solve as much as we can. The -4 in the numerator and the 2 are going to cancel each other out, giving you -2 times -square root of 3. The two negatives will cancel, giving us 2 square roots of 3. And so that's going to be our x coordinate for our rectangular version of this point. So we're going to do the same thing for the y value. Our y is equal to r sine theta, and so that's going to be -4 sine -7 pi over 6. And the nice thing about these problems is they use the same angle. So once we have it circled, we just know that we want to switch out the sine -7 pi over 6 out for our y value at that point. So we'll have -4 multiplied by 1/2. And then, of course, -4 times 1/2 is going to give us -2. And so that gives us our y value. So therefore, our answer, the x and y, are going to be 2 times the square root of 3, the x value, and -2 as our y value. Now, there is a way that you can kind of check these and make sure that they make sense. And the way to do that is you could basically plot the point -4, -7 pi over 6, the original problem if you wanted to, just kind of get an idea of where it's going to be, and then you could look at the rectangular version and make sure at least you're going to end up in the same quadrant. So you definitely don't have to do this. This is just to kind of check yourself. So if we plot -4, -7 pi over 6, we of course go to the angle first, -7 pi over 6, which we already know is right here, 5 pi over 6. And so instead of going in that direction 4 units, we want to go away from that direction 4 units because we have the -4. And so that tells us that our point is going to end up being somewhere down here in quadrant 4. Now, if we went to changing your mind back from the unit circle kind of thing in the polar coordinates, if we change back to rectangular coordinates x and y, if you go over 2 times the square root of 3, that means you're going to be going to the right, and then the -2 means you're going to be going down. And so we would definitely end up in the same quadrant, and so this is a reasonable answer. Of course, if we haven't made any mistakes, it's not going to be wrong, but that's just a way you can kind of mentally check yourself.